Okay, so this is question 18. The question is, a man pulling an empty wagon causes it to accelerate at 1.4 meters per second squared. What will the acceleration be if he pulls with the same force when the wagon contains a child whose mass is 3 times that of the wagon? So, first of all, we have to draw our figures out. So, we draw the first wagon. Look as though there's something like this. That's the empty wagon. So our acceleration is going that way. 1.4 meters per second squared. All right, so then we can label that as our acceleration. Our acceleration 1. And then we have an unknown mass, just a general mass for this wagon. And now we want to figure out the acceleration of that same wagon, but with a child whose mass is 3 times that of the wagon. So we go ahead and we draw our second wagon. A little bit of that, a little bit of that. And now we need to figure out this new acceleration. Acceleration 2. This is what we want to figure out. Now, to figure that out, we need to figure out the mass of the wagon with child. So we know that the child weighs 3 times that of the wagon. So we have the initial mass plus 3 times that mass, which will give us 4 times the mass. So we know that this mass is 4 times that mass. And so now we just have to plug all of our known variables into the equations. All right. So we have the force 1, the first force here, and that is equal to the mass times the acceleration, which we already know is 1.4 meters per second squared. So now we have the second force, which is equal to this mass, 4m, times the second acceleration, which is what we want to find out. We want to find out this acceleration. So we know that the forces have to be equal, as it says that it pulls with the same force when the wagon contains a child and when it's just an empty wagon. So we know that these two equations have to equal each other. So we can do m times 1.4 meters per second squared is equal to 4m times that second acceleration. And what we could start by doing is we can divide by the mass, m, so that these cancel out and then these cancel out. So now we're left with 1.4 meters per second squared equals 4 times that second acceleration. And now what we do here is we just divide both sides by 4. And so when we divide both sides by 4, these 4's cancel out. Then we're left with the second acceleration equals 0.35 and then meters per second squared. Just drop these units down, and then that leaves us with the acceleration of the second wagon with the same force with a mass 3 times that of the wagon inside.